Hi, I'm about to go through question 12 on IMAT 2012. So we have a probability question here. We're told approximately 1 in 14 men over the age of 50 have prostate cancer, and that the level of PSA is used as a preliminary test for prostate cancer. We're given that 7% of men with prostate cancer do not have high levels of PSA, so these are the false negatives, and that 75% of men with high levels of PSA do not have prostate cancer, and these are the false positives. And we're asked, if a man over the age of 50 has normal levels of PSA, what is the probability that he has cancer? Okay, so they're talking about false negatives and false positives. So I'm going to start us off with a table. So you can either have cancer or not have cancer, and have high PSA or normal PSA. So which of these are the false negatives and the false positives? So if men with prostate cancer do not have high levels of PSA, then that's a false negative. So have cancer but normal PSA, so the false negatives will be in here. So FN. And if we have high levels of PSA but not cancer, then that's the false positives. So high levels of PSA but not cancer, so these are the false positives. And as for the other two, if we have high PSA and have cancer, then that's like a real positive, so a true positive. And non-PSA and no cancer, that's a real negative, so true negative. Okay, then, well, if a man has normal levels of PSA, so we're looking at this column, then how would we write the probability that he has cancer? Well, that would just be the number of people who have non-PSA and have cancer, so the false negatives, divided by the total number of people with normal PSA, so divided by false negatives plus the true negatives. Well, now we have this expression, we just need to figure out how many false negatives and true negatives we have and plug them in. So how would we figure out how many people fit into each category? Well, we're told that 1 in 14 men have prostate cancer. So if I start off with 14 men, or let's make it 1400 just to make the numbers a bit easier. 1/14 would have cancer, so that would be 100 men, and 13/14 wouldn't have cancer, so that would be 1300. Okay, so how do we fill in these boxes in now? Well, we want to use the information that we're given, right? So first of all, we're told that 7% of men with prostate cancer do not have high PSA. So 7% of these 100 men have normal PSA. So we put 7 in here, which would leave 93 in here. And we're also told that 75% of men with high levels of PSA do not have cancer. So 75% of the men in these two boxes do not have cancer. So in this column, I have 75% in here and 25% in this box. But then that means that our 93 men is 25% of the total number of people in these boxes. So 93 is 1/4, and the other 3/4 would go into this box. So if we do 93 times 3 to find 3/4, that would give us 279 in there. And we know the total of these two boxes comes to 1,300, right? So that leaves 1,021 in the true negatives box. Well, now we have the numbers, so we just need to plug it into our formula. So false negatives, I have 7, and false negatives plus true negatives gives 7 plus 1,021. And because we want the answer as a percentage, then we're going to want to times 100 to give the percent. Now, this denominator is approximately 1,000. I mean, 28 compared to 1,000 is like really small. So this is approximately 7 over 1,000 times 100. And of course, we can do some cancelling. So it's actually just equal to 7/10, which is equal to 0.7. So we want 0.7%, which we see as answer D.